Welcome. In this video, we'll solve a problem in kinematics related to motion in river. On a river coast, there is a port. When a barge passed the port, a motorboat departed from the port to a village at the distance 15 kilometers downstream. It reached its destination after 45 minutes, turned around, and started immediately moving back towards the starting point. At the distance 9 kilometers from the village, it met the barge. What is the speed of the river water, and what is the speed of the boat with respect to the water? Note that the barge did not move with respect to the water. Give this problem a try. We'll try to solve this problem in two ways. In ground reference frame, speed of the barge is equal to speed of the water as given in the problem. Let T total be the time taken by the boat to reach village and return from the village to the barge. It can be calculated using the total distance traveled by the barge in this time and the speed of the water. In addition, T total equals the sum of time boat takes to reach village and the time boat takes to return to the barge from the village. It is given that the boat takes 45 minutes to reach the village. The boat's speed is reduced by the speed of the water while traveling upstream on the return journey. Therefore, T from village is 9 by V boat minus V water. By combining these two relations, we get our first equation. The next equation comes after considering the downstream journey of the boat. When the boat moves towards the village, its speed is increased by the speed of the water. The boat travels 15 kilometers in 45 minutes. This implies that the sum of V boat and V water is 20 kilometers per hour. Now we have two equations with two unknowns. Let us substitute the value of V boat in the first equation and simplify it. We get the following quadratic equation with variable V water. After a little thought, we can see that this equation can be factored as follows, which implies that V water is either 4 or 20. Substituting these values into the second equation implies that V boat is either 16 or 0. But the only meaningful solution is V water equals 4 kilometers per hour and V boat equals 16 kilometers per hour. This concludes our first solution to the problem. There is an alternate solution by working in the barge reference frame. In the barge reference frame, the barge is at rest while the port and the village are moving to the left. The speed of the boat is not altered in this reference frame, it remains the same for the downstream and the upstream journey. If we look carefully, the distance traveled by the boat is the same from the port to village and from the village to the barge. As the distance and speed are the same for both the journeys, time to village equals time from village. Now the distance the village moves in this frame equals V water times T total. This immediately gives V water to be 4 kilometers per hour. Notice that we did not need to solve any quadratic equation to get v water. To get v boat, we consider the distance the boat travels to reach the village, which will be total distance minus the distance traveled by the village. This gives v boat equals 16 km per hour. As you see, in this frame, all the equations are simpler. If you like this content, please like, share, and subscribe. Thank you for watching. See you in next video.